Here we have the laboratory preparation setup. It is containing the round bottom flask, as you have seen in the book that I showed just a moment earlier. It is the round bottom flask. It is fixed via a stand. We have fixed by a clamp to a stand, and then you can see it is being heated from the bottom, and we have concentrated sulfuric acid, which is one of the key reactants, right? Two reactants we have. One is concentrated sulfuric acid, which is being poured down through the thistle funnel. The funnel is dipped just below the level of concentrated sulfuric acid, which is being poured through this. At the bottom we got some chunks of NaCl. That is our rock salt, common salt. And then we have the reaction here. The reaction is taking place here. Reaction between what and what? Reaction between sodium chloride and concentrated sulfuric acid is taking place here. In this place right here, the reaction is happening. What reaction is happening here? I'm just showing the reaction here. Here NaCl is reacting with concentrated H2SO4 and giving us what? Giving us NaHSO4 plus HCl. This reaction, okay, NaCl plus concentrated H2SO4 gives us NaHSO4 plus HCl. This is happening where? Here, right here in the round bottom flask, and from there the HCl gas is filling up. It's filling up, and then finally it is going through this delivery tube. It is going into the washer bottle. Now in this bottle you can see again we have put concentrated sulfuric acid. Why have we put concentrated sulfuric acid? We have put concentrated sulfuric acid because it is a drying agent. Now two properties of HCl need to be taken into consideration in this lab preparation. Okay, one is that HCl is highly soluble in water. It is what? Highly soluble in water. So what happens when it is being produced here? It may absorb some water, and it is going along here HCl along with some water vapor. So we are passing it through concentrated sulfuric acid to get rid of the water. The water will be absorbed by concentrated sulfuric acid. The water will be absorbed by what? Concentrated sulfuric acid. Okay, and it is a dehydrating agent as well as a drying agent. In this case it will be drying HCl gas. Okay, it will be drying HCl gas, and the HCl gas now which is dry will pass through this into the gas jar. Okay, into the gas jar, where it is another property comes into play. That second property is HCl is 1.28 times heavier than air. HCl is what? 1.28 times heavier than air. So what will happen is HCl will be poured downwards, it will be delivered downwards, and air will be displaced upwards. Air will be displaced upwards, and it will be delivered downwards. So downward delivery of HCl and upward displacement of air will take place here. This gas jar will fill up with HCl, and the air will be pushed slowly upwards and outwards. Okay, out comes the air, and this will be completely filled with HCl. Now how will we know HCl is there? Because one thing is that another property of HCl, it has choky pungent odor. It has what? Choky pungent odor. This odor will give us a hint, but we will only know clearly if we have a test to identify this gas present in this jar. There is a test. I'm coming to that test. But first of all, let me talk about the drying agent once more. Why? Why talk about the drying agent once more? In the drying agent, we use concentrated sulfuric acid. Why did we use concentrated sulfuric acid in order to make it dry, is it not? To get rid of the water vapor present along with HCl. However, there are other such drying agents available. There is quicklime, CaO, there is P2O5, the phosphorus pentaoxide. Those are also drying agents. Why didn't we use them? Why did we use concentrated sulfuric acid? In short, the answer is because concentrated sulfuric acid is actually does not react with HCl. Okay. Other things, if I had used quicklime, CaO, okay, if I had used quicklime, CaO, it would have reacted with HCl and we would have no more HCl. Something else would have been formed. We're going to see each part in detail, okay? Something else would have formed. So we are preferring which one? We are preferring concentrated sulfuric acid instead of any other drying agent. Okay, so let me just recall this again. What is happening here? First of all, we are pouring down concentrated sulfuric acid through this. We are pouring down concentrated sulfuric acid through this, and there is sulfuric acid here. The funnel, the thistle funnel is dipped just below the layer of the sulfuric acid. And here at the bottom there are sodium chloride, pieces of sodium chloride. And the reaction here taking place is this one. Sodium chloride will react with concentrated sulfuric acid to give sodium hydrogen sulfate and hydrogen chloride gas. And what? Hydrogen chloride gas. Now this gas will fill up this part and ultimately have nowhere else to go but through the delivery tube into the washer bottle. In this bottle we have concentrated sulfuric acid. We have what? Concentrated sulfuric acid. In this, why have we placed again concentrated sulfuric acid? We have placed again concentrated sulfuric acid to dry the gas. To do what? Dry the HCl gas. It is acting as a drying agent. It is acting as what? A drying agent. Okay? See, concentrated sulfuric acid absorbs the moisture from HCl. Now you will say, sir, where is the moisture coming from? Obviously, our HCl, which is the important property of our HCl, is that it is highly soluble in water. It is what? Highly soluble in water. So it can pick up water from the atmosphere itself. Okay, it can pick up water from the atmosphere itself. So there may be some water vapor coming along with the HCl that will be absorbed here in concentrated sulfuric acid. Okay, we can use other drying agents, right? No, we can't. We cannot use other drying agents. What are other drying agents? There is quicklime, CaO, there is of course P2O5, phosphorus pentaoxide, and so on, but we cannot use them. Why can't we use them? Because they will react with HCl gas. They will do what? They will react with HCl gas and form something else, some other compound which we don't want. So we'll discuss about that particularly. Wait, but let us first discuss the in general procedure. Then what happens? This will go, the HCl will pass through this and bubble out and finally go through this and into the empty gas tube. Is empty. Empty means what? Filled with air. Empty is always filled with air, at least on earth. Empty means filled with air. So as it is filled with air, HCl is heavier. Another property, very important property, HCl is heavier than air. So what will happen? It is 1.28 times heavier than air. So the HCl will start to fall downwards and there will be upward displacement of air. The air will come out of this jar and it will be filled with HCl. Now how shall we know it is filled with HCl? We will have to test it. We always obviously get a smell. The smell is of a choking kind of pungent odor. But that smell is not sufficient. We can understand, but to make it sure that we will do a test. What will be that test? We will bring a glass rod. We will bring a glass rod which will be dipped in ammonium hydroxide solution, and that when we bring near the mouth of the HCl containing jar, we'll see dense white fumes. Dense white fumes means like white smoke will come out. Okay, white kind of fumes will come out. Okay, those will confirm that indeed in this one there is HCl gas. Okay, so this is the setup. Now I will explain each individual part. And there are a lot of questions from here. Let's discuss this each individual part from here. But the most important thing is that in general idea you have to get about this setup. It is all in page 143. The diagram which I have showed you earlier also. This diagram right here. 8.1 in page 143. This diagram. Okay. The reactants are who and who? NaCl and concentrated H2SO4. And the reaction taking place between them is NaCl plus H2SO4 we keep the temperature below 200 degree and we get NaHSO4 plus HCl. Yes. So these are the reactants and this is the reaction. This reaction is happening where? It is happening in the round bottom flask that you saw earlier. Now this reaction in the round bottom flask, we are saying that below 200 degree. Keep the temperature below 200 degree. Now the question arises, sir, why below 200 degree? Will we not get, if we heat above 200 degree, will we not get HCl? Yes, we will get HCl, but there are certain problems if we heat too much. If we heat too much above 200 degree, there are several problems. There are a lot of problems. Let us discuss those problems now. What if we heat above 200 degree? Now above 200 degree, what happens if we go above 200 degree? What will happen here is, above 200 degree will be same reactants NaCl and H2SO4. However, the reaction will be different. If it is greater than 200, we will get Na2SO4. We'll get what? We'll get Na2SO4 plus HCl. We'll get Na2SO4 plus HCl. Okay? Now Na2SO4, if it is 2 that side, we must balance with 2 here and 2 there also. Is it balanced? Just check. 2Na, 2Na. SO4 is 1, yes, fine. H2 and Cl is 2, fine. Is it not? Are you understanding this? Simple balancing, nothing else. So what has happened here? The product has changed. Is it not? But our main product remains the same. This is our main product HCl we are getting. Okay? But we are getting along with this Na2SO4. Okay? Na2SO4 we are getting. This thing will form a hard crust. This thing will form what? A hard crust. A sticky hard crust will form on the glass. Okay? The glass diagram that we showed earlier, in that diagram itself, I can show you again with the help of this book. Right here, in the diagram here, as the gas comes out, there will be sticky white crust forming here in the glass apparatus, okay? As this sticky white crust will be forming, that will be hard to remove. The glass apparatus will be spoiled. Actually, it's very hard to remove this, and it will also hamper in the reaction. So we do not prefer this, but this is not the only reason. The hard crust that this fellow or sodium sulfate is forming. Sodium sulfate is forming a hard crust, a crust of sorts, okay? That is a layer inside the glass apparatus, okay? Sticky layer, okay? That is not the only problem. The problem is if we heat above 200, we are wasting energy, we are wasting gas basically, because we are using gas burner, so we are wasting gas. There is no point. And also if you heat too much, the glass apparatus may even crack, because we are heating a glass apparatus, remember. So if a glass apparatus cracks, it is of no use to us. So we will always try to keep it below 200 degrees. We will try to keep it what? Below 200 degrees Celsius, okay? Now let's talk about what are the drying agents. Here after it is formed, we are passing to the drying agent here. Drying agent, that washer bottle that you saw, the drying agent is what? Concentrated what? Sulfuric acid, okay? Other possible drying agents are CaO, P2O5, which we are not going to use. We are not going to use these two. Quicklime, phosphorus pentoxide. We are not going to use these two. Why we are not going to use these two? Because these two will react. They will do what? They will react with whom? With our HCl. They will react with our HCl. All this that I am discussing, it is found in here. Remember that I talked about the above 200 degree reaction is right here. This page 143. Page 143, this entire page I am discussing right now, okay? So that is what we need to study from here, okay? And the drying agent part is here. Purification of HCl, okay? We are purifying HCl. We are purifying HCl so that we don't just have HCl mixed with water vapor. We need to have pure HCl, purification of HCl, and that's where the two reactions are given, okay? Let us do this. Now, if we are reacting with other drying agents, which we are not going to use, we shall use other drying agents, okay? If you are using other drying agents, for example CaO, and we pass HCl through this is what quicklime. This is what quicklime. We will get CaCl2 plus H2O. Okay, we'll get what? CaCl2 and H2O. Now it is not balanced, obviously. We have to give a 2 here, I guess. So it is balanced now. We wanted what? We wanted to dry HCl, right? We wanted to dry HCl. However, instead of drying HCl, we are getting totally different products. We don't want calcium chloride here. We don't want water here. We wanted what? Dry HCl, which we are not getting. Okay? Which we are not getting. If we use P2O5 and HCl, we will get POCl3 and HPO3. So basically, here also we can see that we are not getting our desired product. Our product, we don't desire any product here actually. We desire HCl to become dry. Okay? We desire HCl to become dry, and it is not getting dry here, is it? It's not getting dry here, HCl. rather we are getting some other products. We are getting some other products which we actually do not need. Okay, now this is also not balanced. Let's see, if I give a 3 here and a 3 here, H is becoming 3 and 3 here, CL is also 3, fine. P is how much here? P is actually here 5, and here we're getting 3 is a 9 and 1 10, so we can give a 2 here, and we can see here it is 4, and here 3 plus 1 4, yeah. So you can see 2 it is 4, 2 and 2 is 4, 2 to the 4, and here 3 plus 1 4, P is okay, and O is 5 to the 10, O is 3 is a 9, and here 1 10, Cl is 3, H is 3, okay. This is a balanced chemical equation. Okay. Now, what is happening here? P2O5 is reacting with what? P2O5 is reacting with HCl to give you some other products which we don't want. We wanted what? We wanted only to dry HCl. That is not happening. That is not happening. What we are getting is some other product. So what drying agent shall we use? We shall use concentrated sulfuric acid as the drying agent. We will not use quicklime, we will not use phosphorus pentoxide, we will not use these things. Okay? Now, this is under drying, purification, okay? Purification. Now, how do we collect? Collection. Collection of HCl gas. Collection of HCl gas. How can we collect HCl gas? Now HCl gas, as we saw in the diagram, remember the diagram we did just now, little while ago? In that diagram we saw in an empty container, right? We saw something like this, an empty container, right? And in the empty container, after passing through the drying agent, our delivery tube is coming, HCl is collecting at the bottom because it is heavy and air is getting displaced upwards. So we must remember that HCl is collected by downward delivery and upward displacement of air. Why? Because HCl is 1.28 times heavier than air. HCl is what? 1.28 times heavier than air. Okay, fine. Then we talk about why not collected over water. There's always a question, why HCl is not collected over water. We have already discussed this part a little bit. HCl is highly soluble in water. It will, if it goes inside water, it will not come out. It will dissolve in water. So HCl is not collected over water, it is collected over air. It is collected by the upward displacement of air. It is collected by what? Upward displacement of air. Let me write it down. Upward displacement of air. Upward displacement of air. Okay? Now the final part is about testing. How do you know this gas jar contains HCl? How will we know? So, how to identify? Identification of HCl gas. To identify, first of all, we get the smell, the odor, pungent odor. There is a pungent choking odor. Pungent choking odor. The smell is there. But this smell is not sufficient identification. So what we do is, we will bring a glass rod. Okay? We'll bring a glass rod, something like this. This is a glass rod, okay? And this glass rod will have some drops of ammonium hydroxide, okay? As we bring it near the mouth of HCl containing jug, you will see that white fumes will come out, okay? Say white fumes, dense white fumes. If you remember, you have done this practical in class 9. There's a glass rod, we dip it in the seemingly empty container, but it is not empty. There is HCl inside, and this glass rod it is dipped in. This is a glass rod dipped in ammonium hydroxide, okay? Glass rod dipped in ammonium hydroxide, NH4OH, okay? And then we'll get dense white fumes. These dense white fumes are because of formation of ammonium chloride. When we were using this glass rod, which we have dipped somewhere in ammonium hydroxide, and then we brought near the mouth of the HCl containing container, and we will see dense white fumes coming out, okay? Dense white fumes coming out, which are because of ammonium chloride. Let us see the reaction. It will be NH4OH plus HCl, and it will give us NH4Cl plus H2O. So this dense white fume that we see is because of ammonium chloride that is formed, okay? That's why we will see dense white fumes. Thus we can identify that the thing that we have prepared is actually it is what? It is HCl gas, okay? So thank you for today. This is about the preparation of HCl. We will see you again in the next online class.